Our final topic today is entitled Threat and Error Management. Threat and Error Management has been a term around the aviation industry for at least 20 years. It originally started back in the early 90s, I understand, out of the University of Texas. Essentially, it's a way of looking at airmanship, that old concept of airmanship anyway, but in more of an enhanced way. In some respects, enhanced airmanship is a good name for it. I also look upon threat and error management as almost like defensive flying in perhaps a similar way that we look at the concept of defensive driving. And there are some terms in threat and error management that we need to perhaps just get straight in our head. And these are terms that we've heard, I'm sure, around the traps. The first one is the terminology of essentially what is a threat. A threat is essentially something that comes externally towards the pilot that requires some action in order to maintain a margin of safety. Now, those threats can be anything from turbulence or bad weather. A threat can be something that might be going wrong mechanically with the aircraft. Air traffic control in itself can perhaps be a threat to the safety of the aircraft, especially if it introduces a distraction. In some respects, we might even be a threat to ourselves. How could we be a threat to ourselves? Well, we might, for example, go flying with a horrible head cold, or we might be going flying when perhaps we are not as current or as recent as we'd like. So that's the essential concept of what we mean by threat. Now, the University of Texas had introduced this concept called line-oriented safety audits. Essentially, it's something the airlines use where they put an observer in the cockpit of an airliner, not to form part of the functioning crew, but just to watch the crew's interactions and record how many or what type of threats come at the pilot and how they deal with those threats. Do they cause or make an error in dealing with those threats? And there's some interesting data that I thought I'd share with you, and we can perhaps extrapolate some of this, or at least try and frame it in the way that we go flying. What this line-oriented safety data, or LOSA data, has shown us with information coming in from a huge variety of databases, so there's a lot of information here, is that 40% of all threats coming at a flight crew usually come in the pre-departure and the taxi phase, while 30% of threats come at a flight crew in the descent, approach and landing phase of flight. Each flight, on average, the crew has to deal with just over 4 threats on average, and they might be anything, as we've said earlier, from weather or ATC related threats. It might be turbulence, it could be anything. The most common threats facing flight crew are usually to do with weather or air traffic control instructions, or trying to comply with what ATC tell the crew to do. 85 to 95 of those threats are quite successfully managed by the crew, but about 1 in 10 threats lead to some type of error by the flight crew in managing that error, okay? Or managing that threat. Mismanaged threats are mainly in the operation of the aircraft, ATC or weather related. So in threat and error management, the other concept that you'll hear is just this terminology of error. Error is something that we commit as human beings whenever we are consciously awake. We never wake up in the morning saying to ourselves that we're going to commit an error. It's just a byproduct of being human. It's something the pilot in an aviation context might do or fail to do that results in a reduction in safety margin. And we divide those errors up into 2 things, an error of commission or an error of omission. An error of commission is when we do something in error. An error of omission is when we might forget to do something. For example, we forget to change a radio frequency, or we may even forget to put the landing gear down. They reduce our safety margins and they increase the probability of our aircraft entering into an adverse event. So, here's an example on our slide. A pilot inadvertently might select 126.8 instead of 126.7. Not done intentionally, it was just by pure accident. Classic example of a small error. Let's think back to our Foxbat example at the start of our presentation in Port Macquarie. I'm sure the pilot didn't deliberately go flying with the volume turned down. That was an error. It's a byproduct of being human. So, let's talk about errors in the line-oriented safety audit space that we've been speaking about earlier. Interesting statistic here with all this data is that 45% of errors committed by flight crew actually go undetected by the crew. Why? Because we are human. Okay? We've spoken, as you can see there, about errors of commission and errors of omission. It's the approach, descent and landing phase where most errors are occurring, anywhere up to about 40%, as you can see from the statistics. 55% of all errors in that phase are actually mismanaged by the crew. Quite significant numbers, really. And in total, about a quarter of all errors that occur on the flight deck are not managed properly. Now, these stats come out of the airline world, but I thought it might be worthwhile for us to at least have a look at this stuff and maybe think how this might apply to our general aviation and recreational flying that we do. When we talk about error, I think it's also important to look at the other side of error, and that is the concept of violation. And the whole concept about violation revolves around intent. Was it deliberate or was it not deliberate? Violation is something that is intentional. It is an intentional deviation from some rule, from some standard operating procedure or limitation that we do deliberately. And it's all done, or it's all centered around intent. Classic example, a pilot didn't decide to make a radio call to avoid paying landing fees. Classic case of a violation. The real danger with violation is when we are actually successful at it. Because when we are successful at violating, what that does is that it encourages us to do it again, and to do it again, and do it again, and do it again. And we continue being successful at it until one day circumstances might be slightly different and we end up with a major event. Classic case, if you want a good read one night, is to open up and have a read of the accident report of Space Shuttle Challenger. Classic case of what we call the normalisation of deviance. In other words, where intentional violation over time starts to become the norm. Now, in our own flying, for example, we might regularly fly with our aircraft above its max takeoff weight, or it might be out of balance, or we might regularly go flying when the VMC conditions might not exist. We might get away with that. We might continue to get away with that over the years. We might continue to be successful, but until one day something might be slightly different and it results in an accident. Now, all human beings violate. Again, I often think that it's also part of being human. And in our seminars, I will often ask the audience, who here has violated? And you might only get a few hands go up. So then I pose the question to the audience. So who here has gone through a roadwork zone at 45 instead of 40? We all have. We've made a deliberate decision that no, I'm not going to go through that roadwork zone at 40, I'll only go at 45. But it's something that we do intentionally. And again, especially in aviation or other forms of transport, of course, the real danger is when we're successful at it. The final concept when we talk about the idea of threat and error management is this term called an undesired aircraft state. You might have heard this term spoken around the flying club or have read it in magazines, seen it on the Flight Safety Australia website. Accident reports, that type of thing. An undesired aircraft is simply a position or an attitude or a configuration of an aircraft as a result of something that the pilot does or doesn't do that results in a reduced margin of safety. So what do we mean in reality by an undesired aircraft state? An undesired aircraft state might be having an aircraft in a stalled configuration only 100 feet above the ground. That would be an undesired aircraft state. Or be halfway across Bass Strait with only 5 minutes of fuel remaining. Again, an undesired aircraft state. Or an aircraft that punches across a holding point onto an active runway. In other words, wrong place, wrong time. Significantly reduced safety margin. It's what we call an undesired aircraft state. And there's an example there. The pilot might realise their error and hold short, taxi off the runway, realising that the aircraft is in a position that safety is actually reduced. So here's a classic example. An aircraft on the left-hand side, our blue aircraft, taxis past the holding point onto the flight strip of an active runway. An aircraft on short final sees this aircraft taxi across the holding point and readjusts its approach path at the final minute and actually starts to land within the flight strip. Classic case of some undesired aircraft states, and let's start to pick apart this small example in terms of threat and error management. So, what threats can you identify with that scenario? First of all, the aircraft that's taxied onto the flight strip beyond the holding point is too close to the landing aircraft and definitely represents a threat to that landing aircraft. Secondly, the landing aircraft is operating with reduced lateral separation from the aircraft on the ground and represents a threat to that aircraft on the ground. The other threat is that the landing aircraft has a reduced lateral area available within which to manoeuvre, okay? Or to deal with any other thing that might come at that aircraft, such as a crosswind or a handling error. Again, represents a threat to that aircraft that's coming into land. So what errors or violations might have occurred in this example? Okay, let's pick this apart. First of all, the pilot proceeded past a holding point with an aircraft on short final. Was that an error? Potentially. Could have also been a violation. Sometimes you have to dig a bit deeper. What else do we have? The landing pilot didn't go around, didn't actually commence a go-round, even though the aircraft had approached into his runway. Now, there may have been mitigating circumstances. The pilot coming into land may have been running out of daylight. He may have been running out of fuel. There's a bit of light and shade there as well. Could have been error, could have been violation. The landing pilot has continued with what we call an unstable approach, where the rate of descent, altitude, airspeed, aircraft configuration were not within defined parameters. Potential error, potential violation. And there were some undesired aircraft states, aircraft that were in the wrong place at the wrong time. The aircraft is on the runway with another aircraft on short final. That aircraft on the runway was in the wrong place at the wrong time. A classic case of an undesired aircraft state. That landing aircraft was in an unstable configuration, having to manoeuvre abruptly on late final to avoid that aircraft. Again, undesired aircraft state. Wrong position on the runway during the landing and touchdown phase. So, introducing some additional threats in this scenario. The pilot on final approach sees the aircraft approach across the holding point. Says, yes, well, perhaps I could have slowed my aircraft down to give the other aircraft time to vacate. And whilst at that reduced speed, maybe I could have conducted some S-turns, again, to further lose time. Introducing what we call the unstable approach, okay? So we run the risk of trying to manage one threat and putting our aircraft in an undesired aircraft state in trying to manage an external threat. So, what threats might impact on that aircraft on final approach? Clearly reduced safety margin, manoeuvring too close to the ground at low airspeed. Puts that aircraft very much into an undesired aircraft state. Could very easily lead to things like an inadvertent stall and then a spin close to the ground, which would be unrecoverable in the height remaining. We've spoken a lot about undesired aircraft states. We've also spoken a lot about unstable approaches. When we go through the ATSB database and databases around the world, we find a continuing theme that the vast majority of aircraft that run off the end of a runway or have a runway excursion off the side of a runway, the genesis or the original causal factors in that accident can usually be traced back to an unstable approach. We can reduce the risk of a runway excursion by having the discipline when we go flying to ensure that our rate of descent, our altitude, our aircraft configuration and our aircraft speed are within certain defined parameters at various points along our final approach. So what can we do to assist this? First of all, nominate where we are going to touch down and have that point nicely sorted out early in our final approach. Secondly, fly a constant profile. Not too high, not too low. The last thing we want to be doing is making major adjustments to our final approach path as we get closer to land. Know the correct approach speed for our aircraft. Most light and sport and recreational aircraft pretty much have the same type of approach speed regardless of weight. But as we go up in aircraft size and aircraft weight, the ideal approach speed can actually vary quite significantly. So it's important that we have a good knowledge of our aircraft flight manual and the appropriate and correct approach speeds to fly. That's going to give us the greatest chance of preventing a runway excursion, either off the end or off the side. And finally, and this is where it comes down to pilot discipline, if we are not stabilised in our approach by a nominated height, then have the discipline to go around. Don't try and push a bad approach, because often it will end in tears as we spear off the side of the runway or we land too long and we go off the end of the runway. The airlines, for example, are very hot on this. If the approach isn't stabilised by certain gates on final approach, it's a standard operating procedure to conduct a go-round, bring the aircraft round and have another go at landing. Us, as the recreational or the private pilot, should be doing this as well. There's no shame in going round, and if it isn't right, it's a normal type of manoeuvre that we should be practicing regularly, and that alone will help us with our threat and error management, especially when we're close to the ground. I'll leave you with a final example of some threat and error management gone wrong. This was an example at Caloundra in a home-built aircraft. The pilot was coming into runway 05 at Caloundra, recognised that there was an external threat that they had to manage. That external threat were parachutists that were under canopy, and the pilot was concerned that those parachutists may drift across onto the runway strip. So the pilot therefore manoeuvred the aircraft to the right of the runway strip to perhaps give themselves more room. The pilot ended up too high on profile, so therefore too high above the ground, too late in the final approach. Instead of commencing a go-round, the pilot found themselves in that situation and tried therefore in the final stages of approach to regain the correct profile by entering a side slip manoeuvre. The pilot entered the side slip manoeuvre very close to the ground, but in coming out of that side slip manoeuvre, mishandled the aircraft. The pilot unfortunately mishandled the aircraft to such an extent, the pilot lost control of the aircraft in flight, and unfortunately that was the result. 4 people were seriously injured, the pilot especially so. Classic case of an external threat perhaps being managed inappropriately, and errors were made in the management of that threat. Of course, it didn't help that the aircraft unfortunately was also loaded beyond its aft centre of gravity, which increased the chances of the aircraft losing control in flight. Loss of control in flight accidents, the statistics tell us, are accidents that often end up with fatalities. It's not the type of accident that we want to have. So let's review where we've been. You've joined me on a journey through 3 significant topics: communication, situational awareness, and finally, threat and error management. So in communication, the main document that I recommend pilots go to and review is CAP 166, which talks about operating at and in the vicinity of non-towered airports. Remember, non-towered airports, we don't have air traffic control there. As a consequence, the communication that we provide on the radio is even more important. That communication needs to use standard phraseology wherever practicable. Of course, use plain language if you have to, but for all intents and purposes, that standard phraseology is very important. Think what we are about to transmit, think about the audience that we are transmitting to. Am I likely to increase people's situational awareness or detract from it? And we have the greatest chance of spotting other aircraft in the CTAF environment if we use appropriate radio calls combined with a disciplined lookout and a scan for other traffic using our eyesight. Secondly, that communication led on to the building of situational awareness. Remember, we spoke about that 3-step process. Where has the aircraft been? Where am I now? Where will I be into the future? A process that doesn't come naturally, but as we gain more experience, becomes more and more intuitive to the pilot. With situational awareness, it's that one thing that will help us keep ourselves safe and alive at these non-towered aerodrome environments. Also with situational awareness, have a look at our own flying. Learn to recognise the red flags in our own operation. What are some of those little triggers that I need to keep an eye out for that may indicate to me that I'm losing situational awareness? And finally, we put all this together in our discussion of threat and error management. Whenever we go flying, It might be a flight to the other side of the country or a local flight in our circuit. Before we launch, think about what are the potential threats that might come at me externally as a pilot. It might be weather related, it might be airspace related, it might be air traffic control, it might be distraction from other passengers. Think about the threats that we're likely to face and how are we going to manage them. Do I have a plan A? Do I have a plan B? Do I even have a plan C? We often liken threat and error management to enhanced airmanship or maybe even defensive flying, if you like. So that concludes our seminar series for 2018-2019. Thank you very much for joining us. We look forward to seeing you next year with our following seminar.